Previously on our channel we talked about strange visitors from beyond our solar system. Remember Oumuamua in 2017 and 2I/Borisov in 2019? Both turned out to be true interstellar objects, debris from other stars passing briefly through our neighborhood. Well, now astronomers have confirmed a third such traveler, officially named 3I/Atlas. At first glance it looks like just another icy comet. But one astrophysicist has a radical idea: this could be a planet seed, a ready-made starter core for building giant worlds. Every comet you've ever seen in textbooks, Halley's, Hale-Bopp, or the ones dazzling backyard astronomers each year, follows an elliptical loop around the Sun. They may come from the far-flung Oort cloud, but they're still gravitationally bound to our solar system. 3I/Atlas is different. Its orbit isn't a loop at all. It's a hyperbola, an open curve showing that it's just passing through, never to return. This puts it in an ultra-exclusive club with only two other confirmed interstellar objects, Oumuamua and Borisov. Each one has challenged expectations. Oumuamua accelerated in ways that normal comet jets couldn't easily explain. Borisov looked more like a classic comet, but had a distinctly unusual chemistry. Now, 3I/Atlas adds to this small but fascinating sample. Discovered by the Atlas Sky Survey System, it shows comet-like activity but with quirks in its light curve and gas composition that keep scientists cautious. Most researchers still lean toward a cometary explanation. After all, when volatile ices heat near the Sun, they produce jets that can nudge objects off course. But the oddities of these interstellar visitors keep the door open to new thinking. The standard picture says planets form gradually in protoplanetary disks, clouds of dust and gas encircling newborn stars. Tiny grains collide and stick, building up pebbles, then boulders, then kilometer-sized planetesimals, then finally planets. But simulations show a frustrating barrier. Once particles reach sizes of centimeters to meters, they tend to bounce off or fragment instead of sticking. It's hard to scale up to massive cores within the limited lifetime of a disk, which typically disperses in under 10 million years. Yet telescopes like ALMA reveal fully formed giant planets around stars only a few million years old, way too fast for the slow, incremental model. Something must be giving these systems a head start. Enter astrophysicist Suzanne Fiener from the Max Planck Institute for Radio Astronomy. Speaking at a planetary science conference in Germany, she proposed a bold but elegant solution: interstellar objects act as planetary seeds. Think of it as cosmic seeding. Small particles in the disk are far more likely to accumulate on something already massive than to stick together in fragile collisions. The result is a rapid jumpstart to planetary growth, especially for gas giants, which need large cores before the surrounding gas disperses. Crucially, this idea doesn't throw out existing theories like pebble accretion or gravitational instability. Instead, it adds another mechanism that may operate alongside them. Planet formation could be a layered process. Interstellar seeds provide the foothold, and local growth mechanisms finish the job. Seen this way, 3I/Atlas is more than just an odd comet. It's a potential case study in how such objects travel between systems, sometimes captured, sometimes just passing through. If captured by a young star, it could literally become the foundation of a new planet. Astronomers are racing to observe it with big telescopes before it fades. The more precisely they can measure its composition, rotation, and dust emission, the better they can compare it with models of captured planet seeds. If Fiener is right, it changes how we view both planet formation and interstellar traffic. First, it solves the time problem. A captured seed bypasses the slowest stage of growth, letting a giant planet form quickly enough to grab gas before the disk disappears. Second, it reframes interstellar objects not as rare curiosities but as agents of planetary diversity across the galaxy. Each seed carries its own unique composition, inherited from its birth system. Capturing one could introduce exotic ices or metals into a young disk, affecting the final planet's chemistry and potential for life. Third, it suggests that our own solar system might carry such fingerprints. Some outer solar system objects could be captured interstellar wanderers from long ago. Even Earth itself may include material from other stars embedded deep within its rocks. What happens next? Scientists are already planning new surveys to catch more interstellar objects. Projects like the Vera Rubin Observatory will dramatically increase the detection rate, possibly finding dozens per year. Each new discovery is another data point for the planet seed hypothesis. Meanwhile, theorists are refining capture models, how likely it is for a young star to grab an interstellar body, how big the seeds need to be, and what signatures such a process leaves behind. For now, 3I/Atlas is a fleeting visitor, a snowball from another star streaking through our sky. But its significance could be enormous. It invites us to see planet formation not as isolated events but as a galactic-scale recycling program, where systems seed each other with building blocks, jump-starting worlds across light years. It also reminds us that cosmic mysteries sometimes hide in plain sight. A humble comet in a telescope's field of view may actually be a message about how entire planetary systems arise. So the next time you read a headline about an interstellar comet, remember, it might be much more than that. It might be a seed, a grain of tomorrow's Jupiter, Saturn, or even a habitable Earth circling a far-off sun. Thanks for watching. If you enjoyed this deep dive into 3I/Atlas and the planet seed hypothesis, hit like and subscribe for more stories about cosmic mysteries and cutting-edge discoveries. And tell us in the comments, do you think interstellar objects could be the missing link in planet formation? Thank you for watching my channel.